So I will target on the Verona learning study, which is currently evolving now in Europe, and explain what we are doing there. So this is the first large-scale multi-center implementation trial of volume CT lung cancer screening across 5 European countries. And we aim to develop and implement the most optimal and personalized CT lung cancer screening program for high-risk individuals. And also to integrate, and that is where this presentation is focusing on, the comorbidities. So we make a difference between incidental findings and comorbidities in our discussion with the Dutch Health Council. So we regard calcium scores, burning calcium scoring, and emphysema scoring as comorbidities of lung cancer, and not as incidental findings. So I think that's an important issue. So, now yeah, those sentences, you know, probably. This is the trial design. Now, there we should mention that we also, as I explained yesterday, we are studying the stretching the interval for normal baseline individuals to 2 years and compare that with the regular regimen. And we hope that we can indeed do this. So we use the baseline screen also as a predictor for further intervals for the screening program. Now, this is the scan examination, very much simplified. So we do one single scan, also for an optimal calcium scoring. So that is important. So we do not combine 2 scans or something. And that is very much, of course, driven by the fact that we need to stick to very low doses. And we have in our population, for the 3 diagnoses, we do not use more than 0.7 to 1.5 millisievert with a high temporal resolution with the pitch 3 protocol, which I said yesterday we developed with Siemens. And with this, we have proven, now this is the examination, how it works, and nothing new for most of you. It's all fixed. Everyone has the same protocol, and no deviation whatsoever. We included now 3,000 scans. We hope that by the end of August, we will have a double number. And this is how we do the reading. So we will first read locally with the lung cancer package from Siemens, where we did the Nelson study with. So that will be exactly the same translation to the results of the Nelson to Verona lung run by the first reader. Then we do a blinded read by the AI. Yeah, of course, blinded, but the second read by the AI. If there are discrepancies, we will do a third read. And that is centrally. So we have a high performance computer center, which is doing all the data management and the reads. And that third read will be done on the discrepancies. And at the moment, we have a 25% discrepancy read. So 75% is complete in concordance AI with the radiologist in a complete separate manner. Now, this is the management nodule protocol. I will not go into this. Now, important to mention that you are not using iterative reconstruction, as you can see here, as well as in cuts, as well as you use it by the AI itself in a standalone fashion. You see here the same nodule that shifts by the different kernels to different measurements of the volume. And finally, you will even get quite a lot of voxels that are at the region of calcium by iterative reconstruction, by which automatically the nodule is classified as calcified, by which it is benign. So, so we do not recommend and we do not use iterative reconstruction for further dose reduction. We did a lot of work on calcium scoring already from the very beginning that we started with the Nelson study. We did also the Rotterdam calcification study with EBT. Later on, also with CT, and published a lot of data on this. We have now the Robinska study running, and we'll come up with 5 to 7 years follow-up after stratification according to the calcium score in 3 groups. And we hope that there will be a significant mortality reduction for those that are treated accordingly to the calcium score, better than the current methodologies. So that result will be implemented also in Verona, hopefully by the end of the year. Now, furthermore, we developed a non-ECG triggered protocol and validated this. This is also published and also validated with AI. And you can see here that is published in the JAK imaging, that we have very nice concordance, even for the very low calcium scores from 0 to 100, as you can see here. And you can find it in JAK imaging in a non-triggered fashion. That is very important because the protocols that are used at the moment need at least ECG triggering, by which it is not really implementable in a normal screening fashion as we do. So we do not recommend calcium scoring if you cannot meet the demands that are necessary for reliable calcium scoring. You will end up with a very high number of false negatives and positives if you do not do this according to the rules that should be applied for a validated calcium score. Now here you see a typical example. This is a Verona patient with an Egerton score of 644. Now, and that is all automated, so the scores will be there automated, and also per vessel be categorized. So some very first results. We hope that we can publish the first results over the first 2,000 scans in the coming months. And preliminary, we can say that 1 of 3 participants in lung cancer screening are at very high risk for cardiovascular disease. 1 out of 2 may require preventive treatment, and also 1 out of 2 have a very low cardiovascular risk. And this opens up a new biomarker, that is completely independent from everything that is developed at the moment. So perhaps there indeed exists a happy smoker that will not develop any calcium during smoking and will not develop lung cancer. So that this would be a very interesting coincidence. It is relevant because in the population so far, there are, and that is over age of above 60. So that is really relevant for those older ones. And you still find in 20% a 0 calcium score. Then we, last but not least, we do also the emphysema scoring. And after a troublesome way for low attenuation quantification in percentages, we ended up now and we get a real nice or better agreement between the Fleischmann criteria so far. So the reading of the radiologist compared to the AI. And this is what we are now at the moment producing automatically with sizes that are concurrent with the histological dimensions. So we discern from 3 millimeters, so lower than 3 millimeter, we regard as random clustering of noise. Then from 3 to 6, we are in the alveolar dimensions, that's purple. From 6 to 12, we are in the acinar level, that's the green. And from 12 to 16 millimeters, we are on the level of a secondary lobule, so that's the orange. Now this one patient, this is all the analysis that we automatically get. Yeah, it's the end almost. But this is what I really would like to show to you. We are now working with the workload reduction, and also David Jankelevich mentioned this. Can we use AI as a first reader? And we think the answer is yes. And we do task-focused AI. So the first question is, can AI detect the patients without nodules? And it can. So that is a relevant question because 50% have no nodules. So you get already a workload reduction of 50%. Then furthermore, can AI detect nodules smaller than 100 cubic millimeter in a reliable fashion? Yes, it can, and that adds up in another 30%, which now already would mean, if you do it as a first reader, that you can get a workload reduction of 80%. Now, this is all technical infrastructure. I will not bother you with this. This is all in the data management system, so it's an end-to-end solution that we're using. So we have all the figures at any moment in time, and that's it. Thank you for your attention.
Thank you.